Well, you wouldn't know this, but I just recorded this final video here, and but I didn't record it because I didn't hit record. So the idea is, what do you do when you have something that looks like this? Let's say point 357, 357, and that repeats. Oh, what do I mean? What do you do? How do you write that as a fraction, or how do you convert that into a fraction? Now, the method that I showed you to get the formula for an infinite sum or a finite sum in a geometric series, that suggests a shortcut. But to be honest with you, I want to show you the shortcut. To be honest, it was my 7th grade math teacher, Mr. Welkley, who I remember showed me this trick. Stuck with me. Once you know it, it's really easy. How many ever digits repeat? So here we have 3 digits that repeat. You're going to multiply by 10 raised to that power. What I mean is this: if 1 digit repeats, we're going to multiply both sides by 10. 2 digits, 100. 3 digits, 1,000. 4 digits, 10,000. So let's call this S for sum, and I'm going to multiply both sides by 1,000. Now on this side, I'm going to write it in a slightly strange way, maybe. But look, you multiply by 1,000, so we move the decimal over 3 places. So 357 point. But then the 357s keep going, so we have an endless supply of them. And we get this, and I'm going to subtract 1000s minus s. Over here, all those cancel each other out, and we get this. Divide by 999. Oh, that was s. Sorry about that. So s is 357 divided by 999. Done. Finished. I mean, you should check if you can reduce it, which you could here, but I'm not really worried about that right now. One more really quick example. Let's say you had 0.444 dot, and that's our sum. Because 1 digit repeats, I'm going to multiply both sides by 10. Subtract 9s, 10s minus 1s. Over here, all that cancels out 4, so s equals 4/9. So that's pretty easy. Hey, if there was any doubt, I guess I've had people that they get I don't know what the look on their face would be, but I don't know what, they're in doubt or something. I'll just say, bust out a calculator and take 4 divided by 9, and sure enough, you'll get this. Or take 357 divided by 999, and you'll get 0.357357. Now, there's one additional little complication that can get thrown in here, but it's not a particularly big deal, so let me just show you. Excuse me. Suppose we had 0.45777. So there's a little bit of a delay until we get to the repeating section. So 0.45, and then we start 77777. How do we convert this into a fraction? 1 digit repeats. I'm going to multiply both sides by 10. So we'll get 10s. Over here, we're going to get 4.5, because move the decimal over 1 place. 777 dot. We're going to subtract 9s. Now, what do we get here? Look, all these cancel each other out. 7 minus 5 is 2. 5 minus 4 is 1. 4. Divide both sides by 9. 4.12 divided by 9. Technically, this is correct, but it's not cool. It's not tradition. It's not convention. Don't leave it like that. You don't want to have a mixture of a decimal and a fraction. So do not leave it like that. So here's the trick. You've probably seen this before. I sort of want to, quote unquote, get rid of these 2 decimal places. There's 2. So we'll multiply top and bottom by 100. Remember, you can always multiply top and bottom by the same thing, because any number divided by itself is 1, so you're multiplying by 1. So let's multiply top and bottom by 100, and we'll get 412 divided by 900. And again, I should reduce it, but I'm not really concerned reducing this here if you can. So there's the answer. All right. Hey, say good luck on the final, but just do a good job. All right.